Yes. So today's topic is linked list in C. So this is one of the very important topic we are going to learn today. So you are saying that voice is not clear, Niharika. So may I know? Yeah, hello
Sir,
from the.
now it's clear, sir. It's clear, sir.
Is it clear now? Okay, okay,
Yes, sir.
Yeah. Okay, fine. Yeah, fine. Okay. So we'll move with this linked list concepts. So in this linked list, what is linked list and what is the to avoid the problems of static memory allocations, we have used earlier arrays concept, right? So how to overcome those arrays concepts and how we are going to develop the linked list, like memory is going to be created dynamically. Okay, so let us explain all the things. So in this linked list can be defined as a collection of objects called nodes. Okay, so my dear students, so today's session is very, very important, and some people or most of the people, this topic they feel difficult. Okay, so keep in your mind and try to understand each and every topic very clearly. Fine. Now, so linked list can be defined as a collection of objects called nodes that are randomly stored in memory. Okay, a node contains two fields. One is data stored at a particular address, and the other one is the pointer which contains the address of the next node. I'll show you practically what is the node. Okay, so that node consists of two fields. One is the data field, like integer, float, some string, some kind of information. Some data will be stored. Okay, and the other field consists of the next node address. Okay, that also we call as self-referential. We'll see that. And the last node of the list contains pointer to the null. Okay, how we are going to do that, I'll tell you now. See, if you observe this diagram, this is like a node which consists of two fields. One is data field, other one is the link field. So this data field nothing but having some integer. The link field consists of address of the next one. So assume that this next 20 address is something 1002. This address will be stored here. I'll explain that. Okay, I'll explain more in detail. Before that, I'll complete the theory. Why use a linked list over array? Okay, so what are the disadvantages of the and limitations of the array? As you all know, okay, the size of the array must be known in advance before using it in the program. That means you should define the size of the array, right? Like int a of 10, a of 20, 100. You should tell starting of the program, you should define. Okay, so how you are going to define this, the fixed size of the memory you are going to create. Okay, so sometimes, as I already told you, the static memory allocation disadvantage is in case of you are going to create, okay, hotel room booking, how many users you are going to book that room throughout for the 100 years, can you assume? You don't know that. That's the reason you can't fix the size. Okay, so by using the linked list, we are going to create the memory dynamically. Okay, by using MLR function, you already know about this. And increasing size of the array is time-taking process. It is almost impossible to expand the size of the array at runtime. That means once you specify the size of the array with some 50 or 100, after that, if you feel that you want to increase some more size, once the product is developed, again, each and every time developer should, increase the sizes is very risky job. Okay. Once after delivering the product to the client, again, always you need to ask, client will not ask, increase the size, that and this. Okay. There is also disadvantage. So to avoid this, we are going to create the memory dynamically. All the elements in the array need to be contiguously stored in the memory, where in case of arrays, inserting an element in the array needs shifting of all the preceders. Okay. So these are the problems which we are facing during the arrays concepts. Now, all the problems we are going to solve with respect to linked list concept. How? The linked list will allocate the memory dynamically, number one, whereas arrays will allocate statically. All the nodes of the linked list are non-contiguously stored in the memory and linked together with help of the pointers. There is no need of continuous memory allocation. No. Okay. Wherever you want, you can data will be located in non-contiguously. That with respect to the address, we are going to represent. Okay. I'll tell you each and every point. Okay. With practically. So let us open this. Yeah. So now I'm repeating, my dear students. Now I'm repeating. Okay. How we are going to store the data in this linked list? Assume that you want to store 10 numbers or 5 numbers. Okay. Yeah. Say, for example, the number 10 you want to store. Number 10 you want to store, right? So now this in the linked list, we are creating the node. What is the node? See, a node consists of two fields. A node consists of two fields. One is called data. One is called data. And other one is called, you can give any name. In this case, I'm giving next. The field name is the next. This next field is going to store, okay, address of another node. So I'm going to create another node. Okay, another node. Okay, as I already told you, a node is having two fields, right? Same, whatever you have data and next field. Two fields are there in the node. Okay, two fields are there in the next. So this data, assume that this address is like 1002. This address is 1000. Assume that any address location. Okay, fine. Now, okay, this data having number 20. Now, how can we have these two linked together? That means this next to this number is 20. How do you know? Yes, that's why this address is stored here. This address is stored here. That nothing but, okay, this address is stored here, nothing but what? Immediately the next value is where whatever the value is there in the address 1002, right? So that's why this is pointed to this. Okay, pointed to this is nothing but what? Okay, the address. That means from this, where you have to go next, the location is 1002. So this node itself telling you what is the next memory location. So this is pointed to this is the next memory location, 1002 address. Now, okay, so this is it any pointed to any other? That means any other continuation values are there or ending. Yes, assume that there is another value. There is another value, that is another node. If you have a value 30, okay, so we have created, right? So I won't define the size starting itself. As soon as I got the requirement, that means this is like on employee details, having employee number, name and all. I will create a memory, I will create a record, then simply we need to attach to this. How we are going to attach? Simply whatever the, actually we should take 4 bytes for integer, right? So 1000, 1004 and 1008. So this address, okay, will be there here. That's it. This address will be there in this node. Nothing but this is pointed to this one. So you feel that this is the last node? Yeah, nothing but there is no any other ending address. Last node indicates it is null. Okay. So whatever this second field is having null, okay, then we can call it as a ending node. So whatever this is ending node. Now, my dear students, I am going to tell you all the prerequisite to write the program. Okay, ending node. First, to understand this program, you need lot of basics requirements. Okay, so you need more basics requirement here. So I will tell you all the basic prerequisites before developing the program, and then I will move ahead. So now I'm going to open some notepad. Okay, I won't write directly the code. Okay, then you feel very difficult. So before that, I will give you all the prerequisite information. Now, my dear students, you tell me, okay, if you have a structure, this is like a structure. I told you, student ID, student name, like this. If you have a structure having two fields, how do you create? Tell me, like this, structures. Okay, struct. So now my structure name is, I'm saying a node. Node is a structure. Okay, node is a structure. You know this. Now, which is having two fields. What is the name of the two fields? One is the data and other one is the next. So I'm having two fields. One is data and other one is the next, right? So I will create like this. Data consists of, okay, two fields I'm taking, data and next. Fine. So in this data, are you storing the names or integers? Integers, right? So data is my variable. Anything you can take A, B, C, D. So this is of type int. So good. This is integer type field. Now, what is this another one? Another field is a content which is pointed to, same node, nothing but whatever the node is having data next structure is also should have two fields. It should not be, if this is a student data, this should not be a employee data, right? That means now I'm trying to say next variable is the pointer type of variable. Next is the pointer type of variable. Here, this is of type what? This is a variable which is pointed to same structure, nothing but the structure is having again data and the next field. That is called reference, self-reference. Again, this is a struct. I don't want any another node one structure. I'm not pointing to student structure. I'm not pointing to employee structure. You can create like this. If you create like this, what will happen? This is a variable which is pointed to employee structure. But now my structure should be the same structure, whatever you are creating. That means self-reference. This is a variable which is pointed to the self structure. This is called self-reference structure. Very, very important. Okay. So now what does it mean? So my dear students, you should understand very much clear about this. Now again, I'll repeat this. Now, yeah, now I'm going to explain one more time from the program model, right? See, you try to understand very clearly. See, if you're not able to understand the structure node, you will not understand entire the linked list concept. Okay. So I'm repeating. I'm using here Okay, now we have created a node structure, right? Struct node. Struct node. Now, yeah. Again, I'm going to create now. Okay. So a node is created. A node is created. Fine. How many fields we have? How many fields we have? 2 fields. One is integer, other one is the pointer type variable. So now tell me, there are the 2 fields. What is the name of this field? Data. Always it is going to store data. Always it is going to store integers, right? So I may put 10. Now, what is the next field? Next field is, this is a variable of type what? Next. This is a variable of type next. This is going to pointed to, can I write like this? This is going to point to another structure which is having 3 fields. No way. Why? Because this is pointed to same structure node. That means again that node should have only 2 fields. One is data and another one is the next field. Okay. So that is the reason what I'm going to say, tell you. Okay. This is having same node which is having 2 fields. The first field name is the data again. The first field name is the data. Okay. Data, and which is having the numeric values. Which is having numeric value. Okay. Fine. Now you should try to understand now. Okay. This is the next, right? How can you define this 20? Okay. This is again pointed to by the next variable. Fine. Okay. Now here, how to define this one? Where is this data? That is more important. This is not okay, data. Okay. Say for example, there is a variable called A, or I can say node, whatever it may be. Okay, whatever the name I say. Say for example, if I say some header. Okay, if I say header. Okay, so this is a variable which is pointed to by the head. Okay, so how to refer this? Yeah, my dear students. Okay, as I already told you, if this structured variable is something like if I say either head. Okay, if it is a head, if this head is a pointer variable or without pointer variable. If it is a non-pointer variable, how to access this data? Tell me. I can say, okay, as I told you earlier, I can say it is head dot data equal to 10. You please try to remember this. How to access the data members, okay, from this structured variable. Earlier we did it like student ST, EMP, like this. Employee number, employee name, all we have read. Okay. Earlier I'm repeating. Earlier we have EMP. If it is employee number, employee name, something, EMP dot employee number, EMP dot employee name, EMP dot sal. We did it all. Okay. Now, okay, if this is a pointer variable, instead of dot, we should use. Okay, so say for example, I may use the variable head. Instead of dot, I'm going to use arrow operator, right? Arrow operator, arrow of data equal to 10. Are you clear till that? How I'm using this line? Why I'm using head arrow data equal to 10? Why I'm using like this? Since this is a structured variable, that is a pointer type of structured variable, then if you want to access the data members, we should use the arrow operator. If it is a non-pointer variable, we are going to use dot operator. These are the two special operators we are using to access the data members of the structure. Okay, that is the conclusion now. Fine. So here afterwards, I'm going to use like this. So assume that how to refer this 10. So if this is the head of data, head of data. Okay, head of data, how much? 10, right? Fine. Head of data is how much? 10. Now, how to refer this one? How to refer this field? This field name is next, right? So I can say head arrow next. Head arrow next. Okay, this is the head arrow next. So this is pointed to 20. So now if you want to refer, so my dear student, try to understand, this is very important point I'm telling you now. If you want to refer 20, how you can refer the 20? So head of data math, nothing but 10. Now head of next is pointed to this one. This is again having the data field, right? What is this field? Data field, but referred by the head of next. So how to refer the 20? Head of next of data. Head of next of data equal to 20. Are you clear my point? Head of next of data equal to 20. So if you have 30, how you are going to do? How to refer 30? So this is what? Head of next of data of next. Again from here I'm saying, again this all same. Okay, head of next of, again data of next of data equal to 30. Are you clear my point? Then only you will get the 30. This is the data, right? Yeah. Now to avoid like this, what I'm going to do, this next time, that is called traversing. At that time, what I will do, entire head of next, I'll make it as a only one head. Entire head of next, I'll make it as a head. Then always this is going to be head of data. Again, head of next, I'll make it as a head. Then simply my concept will be head of next. If I make this as a head, nothing but what? Head of next becomes head. Simply I can say head of data. Again, this head of next, I'll make it as a head. Okay. So simply this becomes a head of data like this. So like this, I'm going to refer. So the next level, how I'm going to refer? By replacing head of the next with the one head. This is through the program I'm going to tell you now later. Okay. This is going to, I will write the program like traversing. Okay. Yeah. Now, so now here the point is I'm going to refresh again the points. What is the node? A node is having two fields. One is data and another one is the link field, which is pointed to same self node. Okay, that is self-referential. Okay, self-referential. Fine. So now self-referential structure also we call it as self-referential structure. Okay, fine. This is a kind. So if it is a pointed variable, we are using arrow. Okay, fine. Now, what are the various operations we have? How we are going to do? The first one is insert node at the beginning. What is the first operation? If you want to insert the node at the beginning, how you are going to do that? Okay. Yeah, I'll tell you step by step each and every point. How I'm going to do individual node. Okay. Say for example, assume that this is a variable head which is pointed by the, assume that a variable head is pointed to the one node. Say for example, Yeah. Okay. See here, I'm going to point it like this. That means head is having something data. What is the head? You tell me. Once a variable head is having some node, which is having something data 10 or something. Okay. Which is having something data, which is pointed to 10. Fine. Now you take a new node. Again a new node. You want to make this as a inserting at the beginning. Okay. You want to insert 20. Okay. Or 8. You want to add 8. Where you want to insert this? You want to insert after this node or before this node. So we have various operations. Okay. So I'll tell you all the operations. Okay. Now, what are all the operations I'm going to explain to you? Okay. So operations which we are going to do in this linked list are insert at beginning of the node. And the second operation is insert at the end of the node. Insert at end of the node. Insert the new node at specific position. At specific position, wherever you want. Second location you want, third location you want, fourth location you want, wherever you want. The fourth operation is same delete. Okay, deleting starting node. Delete starting node, like beginning node. Okay, whatever it may be. Starting node. Then delete ending node. Delete end node. And then delete specific node. Specific position node. The seventh one is you need to search whether the given node element is available or not. How you are going to search? Search given node is available or not. Search node. You want to display after inserting the data. Okay. You want to display. So display all the node data. Okay. So these are the 8 operations I'm going to explain now. Okay. These are the 8 operations we are going to explain now. Okay. Let's see. Let's see one by one. Yeah, I'm going to do insert at the beginning, step-by-step process. Fine. Now, let's see. What is the inserting the node at the beginning? Nothing but what? Insert the node at the beginning is nothing but what? Say, for example, yeah, you have the data. Yes, you see here. Insert the node at the beginning, nothing but what? There is a new node. Already a node is there. Head, which is pointed like this. You have a null here. Nothing but what? This is the only one node we have. Fine. This is the only one node we have. Say, for example, yeah. Now, you want to take another new node. You want to take another new node that is having the value 8. You want to insert this in the starting position, right? That means after you have to insert this one in the starting position. That means after inserting this, your header variable should point to the node 8. The node 8. After that, this is pointed to 10. First, try to understand the operation. After that, I'm going to write the program for this. 10, it is there null. After inserting, your node should be like this. Then what happened? Now number 8 is inserted at the beginning of the node. Now this is the output. You should get like this. Okay, 8 and 10. Now, if you want to insert the ending, now you want to insert 12. How you are going to insert? That means you create a new node first. You create a new node. After that, insert the value 12. Insert the value 12. You just put this address to here. Nothing but this should be pointed to here. And this null, okay, you put here. Nothing but this is the continuous elements. So 8, 10, 12. So you have now the node is having the sequence of the elements 8, 10, 12. You want to insert a specific position. That means assume after the first element like 0, 1, at the second position you want to insert. Okay. So now you take another node like 11. You want to insert here in between. You want to insert here. So you break this link. So give this link here. Give this link to here. Nothing but, okay, you are inserted in between 10 and 12. So 8, 10, 11, 12. Like this. These are the three operations. The starting node, inserting starting, inserting ending, in between. Let us see how we are going to do the same thing using program. Okay. Again, I will explain everything. So my dear students, Muthureddy and other things. Okay. So at one step, this program will not understand. Again, by writing the program, again through code, I'm going to explain. Through code, I'm going to explain. Okay. Fine. Let me explain through code. Now let us start writing the program first. Yeah, otherwise I'll do this. This is also, okay, this is also a memory, menu driven kind of program. This is also a menu driven program. Okay. So first, instead of all 8 operations, okay, I will explain one by one. I'm going to explain ending, okay, all the 8 operations. Now, let me explain one by one. Yes. So this is singly linked list. I forget to tell you one more point. There are 4 types of the linked list. What is that? 4 types of linked list. The first one is singly linked list. Second one is double linked list. Third one is circular singly linked list. Same thing. The fourth one is circular double linked list. Double linked list. Okay. So now we are talking about single linked list. A single linked list is having how many nodes? 2 nodes. One is data, another one is the link node that we call it as next. Simply, I can call it as link node. That means which is linked to the another node. Okay. Let me explain with practically. Now I'm going to create hash include stdio.h. Include std.lib.h for exits and other thing. Now I'm creating the structure. What is the name of the structure? As I told you, we have two variables. One is int data and other one is which is pointed to same node, struct node. The field name I'm calling it as a next. Okay. So how can you create a structured variable? Simply I can say, assume that my variable is the head. What kind of variable head? This is going to pointed to again struct node. So that's why once if I write like this, this is the variable which is of type struct node. That means a node, whenever I write like this, my dear students, you should understand that a node which is having a data and next field, that is pointed by the head. That is pointed by the head. You should understand like this. Okay. Now again, whenever it is required, again I will execute from the starting. Now till this time, okay, I have created a node. I have created a node. I have created a node which is having data and next, but I don't have any text, right? I just created an empty node. Okay. So what is the variable name? Head. So what does it mean of struct node pointer head? Very, very important. Very, very important. Struct node pointer head is nothing but what? Head is the variable which is pointed to, what is this? This entire thing we call it as a node structure, right? This entire thing I'm calling it as a structure name is called node, which is pointed by the variable called head. Are you clear, my dear, till now? Okay. A node which is having two fields, data and next. Okay, which is pointed by the head. How can I refer the data? Head arrow data, like this. Okay, keep in your mind. Then I'm going to write this next step. I'm going to do two functions. One is insert and another one is display. So void begin insert. Okay, big insert, beginning insert. So why I'm writing like this? I'm going to insert beginning, specific position, ending. So that's why BEG, beginning, insert, end, insert, like that I'll write. Okay. So there are two functions. Without, can I show you only with insert? After inserting whether the data is inserted or not, how can you check? By writing function called display. Now I will start my main program. Void main. Okay, and I will take int choice equal to 0. I'm going to write my program. While choice not equal to 3, 1, 2, 3. I may say 4 also. Why? Because 1, 2, 3 options I'll write 4. Choice not equal to 4. Then what I can say? Simply, I will add later all the 8 operations. Now I'll tell you with 2 operations for better understanding. So printf. Okay. I can say this is the main menu, right? Simply main menu. Simply it is going to get some kind of statement, main menu, which will be printed. After that, I can say printf. I can say simply select option, right? I can say select option from the list. I want to select the option from the given list of the options. I'm going to select. Now I can say printf. What are the options I'm giving? 1, insert at beginning. Later I'll add all. Insert at ending, insert at middle at a specific position, deleting. All the options I will add later. Okay. Now, what are the main prerequisite? Okay. I'll say display, otherwise show. Okay. You want to show all the options. Simply I can say, when I select the show, I need to display all the options. Now, the third option is exit. Third option is exit. Okay. Later, I will add insert some more. I'm going to tell you 8 operations. Now, after this, you need to enter your choice, right? You need to select your choice. So simply, we can say enter your choice. What is your choice? You read scanf %d, comma, ampersand, choice. You read. So this kind of minute-driven program is very important. Once your choice is one, either 1, 2, or 3, or anything, right? So you are going to write in the switch cases. Switch off choice. Under the choice, if it is a case 1, you are going to use your function. What is your function name? You said begin insert. What is your function name? Begin insert. I'm going to copy this function name. Any name you can write. Okay. This is the begin insert is the function name. Then I will use break. If it is the option is 2, you can say display. My function name is the display. I'll use the same. Okay, display. Okay. Now, if it is option 3, then it is exit of 0. Other than that, I can say default printf. Please enter valid choice. Please enter valid choice. You can say like this. So now, this is a minute driven we have written. Okay, now finally, after come out of my main program, I need to implement begin insert display, right? So if the option is 1, control, if the user selected 1, then your variable is having 1. So switch off 1 is true. So then it is going to control move to the begin insert. So I'm going to implement begin insert, right? So begin insert function I should write here. If your option is 2, I should write display. I should write white display. Control will move to here and I should write here. So this is the total code, right? Now I'm going to write the program, how I'm going to insert the node, right? So here we should check various things, whether it is empty, starting, how you are going to create. If the already content is available, how I'm going to create. Okay. I will write the code and I will explain each and everything detailed. So here I always create a variable is of type pointer variable should pointer. What does it mean? I already told you PTR is a variable which is pointer type variable which is pointed to the node. Nothing but a PTR is having a data and a node. Okay. And I want to store some data item. So that's why instead of data, I'm reading a variable named item. Variable name is item. So now I just have to store something value. Say for example, I take one variable item, in that I may have 10. This 10 I'm going to store it here, right? How I'm going to do, we'll see. Okay, to store integer values, I have written item. Now tell me the very important one is. Okay. Now, how can I create a memory like this dynamically? How to create a memory dynamically? By using function called malloc. We already discussed dynamically memory creation. Do you remember this? malloc. dynamically creating the memory using malloc. Okay, fine. So I'm going to create a memory like this. PTR equal to, earlier I have written int. Okay, struct node star malloc size of struct node pointer. See, you should try to understand this one. If you want to create integer size, simply I have written malloc. Earlier, you try to remember. Earlier we have written, okay, int pointer malloc size of int. Do you remember? I written like this to create integer memory. Now I don't want integer. I want an entire structure. So you just substitute, instead of integer, you substitute. It is not data type integer. It is of type a structure. The name is node. Return type. And the size also, it is not a integer. It is of type struct node. Okay. Simply you substitute with struct node. Are you clear? So like this, we are going to create a memory of a node structure which is pointed by the variable PTR. Then nothing but what? So now this name is not header. Now the name is like, I will rub this. Why? Because earlier I just given as a head. Okay. Already head is also one variable, right? I don't want to clean this. Fine. Now what happened? Now I just created one node that is pointer, right? So there is a node, same node, which is having data and next, and which is pointed by the variable name PTR. Are you clear my point? Which is pointed by the PTR. Now a PTR is variable is created, which is having data and next a node is created. Fine. After that, what we will do? Okay. So this is every step by step is more important. Okay. Every step by step is more important. Try to understand. Now, is it starting created or already PTR is pointed to any predefined nodes? It is very fresh node, right? Empty node. So that's why. So if it is created successfully, this is pointed to some memory or not? It is pointed to some memory. Okay, it is not null. So in case it is not created memory properly, it returns null. So I will check whether it is null or not. So if PTR equal to null, it is overflow. Okay, so print sometimes overflow, or it is memory is not created. You take something, anything you can define. So now that means memory is not created properly. Else, now it is pointed to definitely something, some memory location. Then what I will do? I need to read some value, right? Print of 10, 20, 30, as I told you, we should read it. So now enter value. Okay, enter value. Where I want to store enter value, that's why I have taken integer. So I will take the value in the variable percentage comma item. Fine, up to this is very nice. Now let us move. Now this is the pointer. Now if I want to put something data 10, how can I write statement? Now tell me. If I want to put this 10 into this pointer variable PTR, as you know, this is a node, is the first one is the data, and the next one is the next, as you know, since the node is having two variables. Now, how can I put the value 10? So PTR of data, right? How can I put the data? PTR, okay, PTR arrow data. PTR arrow data equal to item, where you have this item, right? This is the statement I'm going to write. PTR of data, nothing but this is the field. So now I'm going to write, we try to understand each and every statement. PTR arrow data equal to item. Okay. So my item is stored in the whatever the PTR which is pointed in the data field we have stored. So what is the next? We have two fields. In the next equal to pointed by the head. Head is also a variable which is pointed to the head. So I can say the same thing, I can call it as pointed by the head. The same thing which is pointed by the head. Simply I can say PTR of next, nothing but this. PTR of next is pointed to the next head. Okay. Then I can say PTR equal to head. So nothing but, so simply this everything you can call it as a head. So I'm going to write, which is PTR of next is pointed to the head, and head here afterwards I can call it as a PTR. Then I want to print one message called node inserted. I can say node inserted. So by writing this statement, I can say that one node which is created, with respect to the pointer, I kept 10. So after this next is pointed to whatever I say header, and I can say this header itself as the PTR itself as a header, nothing but for the first element. So finally, after inserting this, what is your output? Again, as a fresh diagram, all right. So you should understand everything clearly. After creating everything, what is your node? After inserting the first node, this is your node. So which is having 10. Which is having 10. This is pointed by the head and also pointed by the PTR. Okay. This is the content. Next is the null. Okay. Every ending will be the null. Okay, fine. So this is the first element. So now after this, like this, if you insert, again, if you want to do the same operation, again, you want to do the same operation. Okay, now let me run this. Again, you want to do, okay, display will see later. Again, if I run one more time, begin insert. Now you try to understand how I'm going to do. You try to understand. This is more important. Try to understand. Okay. Now you will get very clear. For the first time, it is like this. Okay. If you want to insert one more thing, how I'm going to happen, you see. Now, again, another variable is created. That means a new memory is created. Okay. A new memory is created. That is pointed by the PTR. After this, is PTR null? No. So enter the value. Yes, I will enter the value in the item. So PTR of data, that means my data value is 20. I entered. My data is 20. That means where I kept PTR of data. This is the data, right? You know, data and the next. And the next. Okay. Yeah. Now, see, this should going to be header, right? After this, this thing will be there. Now, what happened? So you try to hear PTR of data. PTR of next, I want to become a header. Nothing but, that means this header is attached to the PTR of next. Where is the header? This one. So this header, I want to attach to the PTR of next. Who is the PTR of next? This one. So this I am attaching to this. So header is attaching to the PTR of next. That's it. So again, this PTR, I'll call it as a header. So this PTR, I'll call it as a head. Is that clear? So head is nothing but first number. So head is pointed to first number 20. This is pointed to the next number is 10, like this. Then it becomes same thing. It becomes now like this. Now I'm redrawing. First one is I'm rewriting head, which is pointed to the number 20, and this is pointed to this PTR, that is 10. That's it. Ending will be null. So now this is inserted first node. Now then you got the 20 and 10. Again, how you want to create? Same thing. If you run, what will happen? Yeah. See, after inserting same thing, what will happen? Okay, same will be repeated. Okay, how we are going to do? See, again, another node will be created. If you want to insert beginning, same program, is it executed for this? Now you want to insert, okay, something like 8, something like 8. This is PTR. This is PTR. PTR of data is 8. Okay, this PTR of next is header. So this header is going to point to here. That's it. Now I don't want to say as a PTR. I'll rename as a head. So it is going to be head. That's it. Nothing but head is pointed to 8 followed by 20 followed by 10, like this. So like this, you are going to insert beginning. So now after inserting everything, how do you know? You want to display, right? You want to display all the continuous values. Then only you will understand. So that's why I will write another function, display. I'll write another function, display. So I'll run this program properly. Then you will understand better. So in the display, again, I need another variable that is of struct node PTR. My variable name is PTR. I always use it to take PTR equal to head. I will read until null encountered. So if PTR equal to null, PTR is null, that means empty. In the starting, if the PTR is null, I can't print anything. So that's why I can say printf nothing to print. And then yes, if you don't want if, then it is not null. That means it will move to the else path. Else, what I can do, I can print values. Simply I can say printf values in the list are values in the given list are, I want to print it. Yeah, tell me how I'm going to print until reach to the null. That means PTR is not equal to null. If it is not equal to null, what I want to do, I will print the value. Always the value is, assume this is the PTR. Is the PTR null? No. So you want to print 8. How are you going to print 8? PTR of data, right? The node value is what? Data. So how you can print it? PTR arrow data. 8 will be printed. Then move to the next pointer. How I can say my pointer is here, PTR, or variable. If I want to move to here, how I can move? This time PTR should be moved to here. How I can say this PTR, I want to say as this one, nothing but PTR. This is very, very important step, my dear. Please try to understand. PTR of next, nothing but this is the PTR of next, right? PTR of next, I will make it as a PTR. I will make it as a PTR. That means this is the PTR of next, nothing but this is. This next PTR of next, I want to call it as a PTR. So can I say PTR of data is 20? Yes. So always I will print a PTR of data. Always I will print PTR of data. That will give you my number 8. Okay. First time PTR of data, nothing but I got 8. Next time PTR of data, nothing but what? I should make PTR of next as a PTR. Then my PTR will be coming to here. Then I can say PTR of data, nothing but 20. My dear student, is it clear or not? Is it clear or not? This is very, very important. If you not understand this point, it is very difficult. Now again, if I say PTR of data, it should be 20. Fine. Again, how I can move my PTR to here? How I can move my PTR to next node? Simply I can say this is a PTR. The next node I can call it as a PTR of next. So PTR of next I'll make it as a PTR. Simply if I want to print 10, I can say PTR of data. Then this will be printed. So like this, you can move a traverse. This is list traversing so that you can print all until PTR point to the null. If it is a PTR is null, then simply you can stop it. Okay, so I can move like this. Until null, I can print. So printf, what I'm going to print? %d or %5d, comma, which value? PTR arrow data. PTR arrow data. So this data value I'm printing. After printing, what I want to do? I will make PTR equal to next element, right? PTR of next. That means always PTR of next, I'll make it as a PTR. If it is not null, simply I'll print the PTR data. Again, if there is any next data, I'll make it as a PTR. Simply I'll print the PTR of data until the next element is the ending element is the null. So this is the step to print the data after inserting. So this is the thing. Now let me run this. Save slink 2.c. Yeah. Let me run this program. Yes, see here, my program is executed successfully. So what are the options we have? Select option from the list, insert at the beginning, show, exit, enter your choice. I want 1. Enter the value. I will enter 20. Yeah, node inserted. Again, my menu is displayed. Shall I insert one more time? Yes, enter your choice 1. Nothing but I want to insert at the starting. Can I insert before nothing but before 20? Can I say 18? Yeah, I want to insert 18. So now 2 elements are there. Let us see where it is inserted. So if before 20, if 18 is inserted, your elements will be 18 followed by 20, right? Let's see. So I want to display show option. Second. Yeah, see. What are the elements? 18 followed by 20. That means before 20, my element is inserted. So the main menu should come the next line, right? That's why I will enter 3. That is exit. So before menu, what I will do, I'll print like this. Okay. Now let me save and run one more time. Now, my dear students, try to understand. Now insert at beginning. Yes, enter your choice 1. Yeah, enter the value. I'll make it as a 20. Now, node inserted. Node is inserted. Again, menu is repeated until you press exit. Now, node inserted. Again, my option is 1. I will take 19. Okay, again, node is inserted. Again, I will take option 1. I may take 17. Again, node is inserted. I want to display. So option 2, I have selected. So you try to understand. Before 2019 is inserted, before 1917 is inserted, any number, whatever the number you insert, is it inserting before this or not? So it is inserting before only. So yeah. So this is the way we have inserted the element before the node. So only 2 options completed, 2 operations, inserting at the beginning of the node and display, that is traversing. Now we have 6 more operations. You want to insert at the ending, you want to insert at the middle, you want to delete, we have a lot of options. Now let me explain another operation, that is inserting at now I'll select the option 3. Okay, now I'm going to this program. Now I want to show you. So insert node at the beginning is completed. Now what is the next operation? Yeah, first I'll complete this. Insert node at last. How can you insert the node at the ending? If you have already something data, okay, insert the node at ending. How can you do this? Okay, that means already you have something 10. Which is pointed here. Assume it is 20. Again, it is pointed to 30. Now you want to insert 30. Okay, which is pointed by the header. Now you want to insert another node. Already here null is there, right? That means this is not pointed to anything. That's why it is null. This is null. Now you create another one. How I'm going to create? As I told you, my program is always created with the variable temp or PTR, right? Sorry, it is PTR. My variable is the PTR is pointed to one new node. Again, you know the data. So you know PTR of data equal to item 40 you put. Now whatever you said here, again one node of next and next and next. So this null, whatever you have, okay, so we should assign this to here. You should assign to, that means your PTR should be assigned to this node. That means assume this is a one variable of next should traverse. So always, always this, whatever you feel that this is something like you can say temp. So temp of next equal to PTR. Temp of next equal to PTR. Okay, that's over. Temp of next equal to PTR, nothing but what? Assume that this is a temporary which is pointed to here node. Temp of next equal to PTR, nothing but this PTR becomes next node of this. And then this PTR of next we can put as a null. That's it. That nothing but ending at inserting node at ending. How can we do this practically? Okay, how can we move? This is the one variable which is pointed to this like this. We'll see. So how can you insert. How can we insert? At the last node. Okay. Yeah. So I'm going to write this program for this. For the same program, I will add. For the same program, okay, I need to add like this. So here I'll change. Control C, Control V. Second option is insert at ending. Insert at ending. Third one is the show. Fourth one is the exit. I can say 5. Okay, fine. So I want another node that is last insert. I can say void last insert. Okay, when our option is, when our choice is 2, it should be last insert. So what I can say here, case 2 is last insert. Okay, and then followed by break. Case 3 is for display. Case 4 is for exit of 0. Okay, so whenever you select the last insert, I'm going to write a new function here. I'm going to write a new function here. What is my new function? Void last insert. Likewise, this is very big program, my dear students. This is big program. Okay, this is very big program. You should practice very well. I'm going to explain step by step. Okay, one by one options I'm explaining. If I explain all 8 operations at a time, you'll get confused. So now let me complete this last insertion. After that, we'll try to insert, try to see how whether it is inserting the ending or not. So now let me create struct node. I want 2 variables. One is pointer variable and I need a temporary variable. Always my variables are pointing to the node only. Okay, fine. That you should try to understand. Now for reading any item, I'm taking integer item, right? Int item. Now I want to create a new node, right? First, whatever you want to insert, you should create a new node. What is the name? PTR, right? So using malloc. So struct, same statement, struct node pointer. Okay, malloc size of struct node. Okay, so same thing, whatever you're writing here, same thing you can put here otherwise. Okay, fine. Then next, if PTR equal to null, something, I'll get something overflow message, else I'll start my process. Now I want to read a number which you want to store into the linked list, right? So I'm going to say enter value. So now I'm going to read the value. Where I'm going to read the value? Into the item, %d comma ampersand item. I am going to store into the variable item. Now, yes, how I'm going to assign PTR of data, right? Already I told you, PTR of data equal to item. PTR of data equal to item. That's the way directly we are assigning the value. Now here you should understand one thing. If the head is null, that means in the whether you have one element or multiple elements. Okay, whether you have one element or multiple elements. If you have only one element, this condition becomes true. If your head equal to null, if your head equal to null, then immediately your PTR of next will be the null. Your immediate PTR of next will be that means starting. Okay, in the starting element itself, you want to select this option. This is the one. The very starting itself, if you select the first option, then your head will be null. Then your PTR of next is going to be a null. And then I can call it as head equal to PTR. I'll explain again with this code. Printf, my message is node inserted. That means for the first time, first itself you want to select this option, this condition will be executed. Else, that means already you have something node. After this you want to insert. Then it comes to the next. Then already whatever you have something header, you make it as a temp. Already you have something header, you make this as a temp. This is very, very important step. Always this temp of next is not equal to null. Temp of next not equal to null. Then you can make temp equal to, just now I told you everything traversing. How you can traverse? Always temp of next, make it as a temp. Temp of next, make it as a temp, then move. Okay, like this, till temp of next not equal null. What does it mean? So this is your temp. This is your temp. You need to move to here. You need to move to here. Okay, then only you can insert temp of next. In place of temp of next, you can attach this one. So whether I'm checking how many times I need to move, first time, second time, third time, like this. If you have only one element, only I need to move one time. If you have two elements, next time. If you have three elements, next time, like this. How you can move? Temp of next equal to temp. Now this is the temp. Then if temp of next becomes temp, like this, till temp of next equal to not null. Okay, now this is, if this is the temp of, is the temp of next is null? Yes, temp of next is the null. Then you stop. So if the temp of next equal to null, then you stop. Okay, until that you have to move. So this is very, very important step, just to move temp to next position. Finally, after you are stopping, what do you want to do? You need to assign this to this one, right? This is the new one. You need to assign this to existed one. How I'm going to do this? I told you, your PTR, this is your new one. Your PTR, you want to make it as a temp of next. I can say like this. That means what? Your PTR, I can keep like this here. Your PTR, I make it as a temp of next. So this is, little difficult to understand. You can practice by your own with, basics, whatever I'm giving. Then immediately PTR of next, you make it as a null. Then I can say printf node is inserted. So this is the way you can insert the node at ending. So actually these three steps will be after the while. Okay, so I'll put like this for better understanding. Let's see how it is going to be happen. Let's see how this is going to be happen. Yeah, did I inserted everything? I have inserted in the case and I have inserted here. Okay, let me run this. Yes. See now, let's see Earlier we have seen the value is inserted at the beginning. Now first I can say enter your choice 1. I'll say enter the value 20. Fine, node is inserted. Now you tell me, last time we have inserted before 20, right? Now we'll do both. Okay, now we will do both. Now I want insert at ending. That means after the 20 it should be display, right? Now again I will select the option 2. That means insert at ending. My element, the value is 22. Enter the value is 22. How can I check it? Node is inserted. How can I check whether the 22 is inserted after the 20 or before the 20? So you should select the third option, show option. Then only you can see. Now I can say show option. See, your element is inserted at the 22 after the 20. Now your data is 20 followed by 22. Now you want to insert at the beginning. Now you want to insert at the beginning. So let's check it. I'll select 1. Then I will enter something 18. Not only 18, you can say 99 also it will be inserted. It is not like, my dear student, it is not like based on the number. I can say 99. 99, where you want to insert that 99? In the first position. That is going to be happen. Let's see, with the third option, you select this show, then only. See, 99 is inserted at the first position since you have selected the choice 1. Okay. Now you want 88, you want to insert. Where you want to insert? Insert at ending. You want to insert 88 at the ending. Okay, let's see. Again, select option 2. Now the value is 88. Let's see. Node is inserted. How can I check it whether the 88 is inserted or not? Let's see with show option. Now my choice is 3. See, is your 88 is inserted at the ending or not? So like this, you can insert the element at the starting and ending. I hope. Okay, I hope you understand. Okay, inserting the elements at the beginning and at the ending and displaying the data. Now, I will explain one more time. The fourth exit option is 4. That's it, you have exited. Okay, now I will repeat the execution of last insert. I'll repeat execution of last insert for better understanding. Okay, so now let's see. I think we don't have much time, but still within stipulated time, I'll try to show you the execution one more time. Yeah, see, I'm repeating. If you have already the values, you have created the pointer when you have selected the last insert. By the time of selecting the last insert, what is your position? That means already do you have the elements like, okay, already you have the elements like this 10 and 20, like this. You have 10 and 20, 10 and 20 already, which is pointed by the head, Here we have null. This is the case. Now try to understand. Now you want to insert the new thing. Now what happened after inserting this? Yeah, a PTR with the pointer node is created. That means a node is created. With the which is pointed by the PTR. That's why that is the statement. PTR equal to struct node of malloc, right? So a variable PTR, okay, which is pointed to a node. Node is nothing but what? We have the data field, we have next field. Okay, fine. This, as you know, it is not null, it is having something. Now coming to the else part. I'm going to explain this part. See, it is okay. I'll move here. My God. Okay. Now, what I'm going to do? Okay, you want to store the data into this value. Okay. What is the meaning here? Enter the value item PTR of data equal to item. Now, what is the PTR of data? PTR of data item equal to something you insert 30. Yes, fine. Now, what is the next part? What is the next part? If head equal to null, if head equal to null, is your head is null? No, already you are having something data. Already you have something data. So I don't want to. So I don't want to move. So I'll come to else part. Now this head I can call it as a temp. So I can call this as a temp. I can call this as a temp. Now temp of next not equal to null. Temp of next, is it not equal to null? True or false? Yes, true, right? What is the temp of null? Is it null? No, it is 20. Okay, so then immediately temp of next I'll make it as a temp. Nothing but what? So this temp of next I'll make it as a temp. So now this is the temp. Okay, so is temp of next is null? Yes. Now till that I have executed. Now is the temp of next equal to not null? False. Actually temp of next is the null. That means we are moving. This statement is for what? Moving till the last node your temporary variable. Then immediately your pointer variable I can call it as a temp of next. I'm assigning pointer to the temp of next. Okay. So your pointer assigning to whom? Temp of next. Temp of next is this one, right? So your pointer is assigning to temp of next. Nothing but what? You have given the link pointer to the temp of next. That's it. Then immediately pointer of next equal to null. So your pointer of next. What is your pointer of next? I'll put as a null. Nothing but what? This node I have given pointed here. Then I kept null. Over. Nothing but what? This is the end node. You are treating as a end node. Okay, I have created first empty. I just given the link to the previous data. Then I kept this as a null. So all the values are there in sequence. 10, 20, 30. That is the thing. That's it. Node is inserted. So this is the way we can insert the node at the ending. Next time, assume that next time if you want to insert one more node, what happened? Again, you create a pointer. Again, you take 40. Okay. Again, you take as a temp. Temp will move to here. Again, this move to up to here. Okay. Again, this is not pointer, right? Again, you move temp up to here. Okay. Then simply same logic, right? Temp of next equal to PTR. Then nothing but that is the value. PTR of next is null. Then you put the null here. Over. Like this, you can add ending. So by this code, always you can add the node will be inserted at the ending position. Okay. So this is the concept. Okay. This is the concept. So like this, you can insert the node ending. Fine. Thank you. So you just practice inserting the node at the beginning and ending and the display. So till now we have seen only the insertion. In the next class, I'll show you inserting at a specific position and deleting. Okay. So like this, you are going to learn these insertions in the single linked list. In the next session, we'll see the rest of the operations. Till then, happy learning. Thank you. Yeah. I'm going to stop the session, madam.